need to enforce strict output formats for your AI tools without sacrificing flexibility. You'll see how to define custom output schemas in FastMCP that guarantee structured responses, while still allowing your tools to return rich content. The pattern uses explicit JSON schema definitions to ensure your AI always receives data in the exact format it expects, with both human-readable content and machine-processable structure.
At MCP, tool output schema equals type object, properties, data type string, metadata type object, def custom schema tool dict, tool with custom output schema, returns data, hello's metadata, version 1.
This demonstrates the output schema pattern for structured tool responses in AI systems. The decorator-based approach lets you explicitly define the JSON structure your tool will return, creating a contract between your backend and AI clients. What makes this distinctive is how it bridges Python's dynamic typing with the strict schemas AI models need for reliable interaction. The pattern works by separating data structure from implementation logic. Your function returns native Python objects, while the decorator's schema definition ensures those objects conform to a predictable format before reaching the client. This declarative approach maintains clean code while providing the validation and documentation AI systems require to use tools effectively. This matters because AI models need predictable, well-documented interfaces to interact with external systems reliably. By defining output schemas, you eliminate ambiguity in tool responses, enable better error handling, and allow clients to validate results before processing. The trade-off is slightly more upfront definition work, but the payoff comes in more robust integrations and fewer runtime errors in production systems. Let's break it down line by line.
At MCP, tool output schema equals type object.
This defines the tool's output schema using JSON schema, enforcing strict response validation. The decorator ensures AI models receive consistently structured data, preventing runtime errors from malformed responses.
Properties
defines the schema properties for the tool's output. This is where you specify each field's type and constraints, ensuring the AI receives structured, predictable data. Follows JSON schema standard for validation and documentation.
Data type string.
This defines the data field in the output schema as a string type. It enforces type validation on the tool's return value, ensuring the data key always contains a string and preventing runtime type errors when the AI processes the response.
Metadata type object.
This defines metadata as a free-form object field in the output schema. It enforces no structure on the contained data, allowing arbitrary key-value pairs while maintaining type safety at the top level. Critical for tools that need to return flexible metadata alongside structured data. This closing brace terminates the output schema definition for the @MCP tool decorator. It finalizes the JSON schema structure that FastMCP will use to validate and document the tool's output, ensuring type safety between Python and AI model interactions. Closes the decorator's schema definition. This final parenthesis completes the @MCP tool configuration, locking in the output schema that FastMCP will enforce for this tool's responses.
Def custom schema tool dict.
This defines the tool function with explicit dictionary return type annotation. The dict declaration enforces type safety and documents the expected output structure, matching the schema defined in the @MCP tool Decorator.
Tool with custom output schema.
This docstring defines the tool's purpose for AI models and human developers. FastMCP uses it to generate API documentation and tool descriptions, while IDEs display it as hover help.
Returns data. Hello's metadata. Version 1.
This returns a dictionary matching the declared output schema. The structure ensures type safety and predictable responses for AI consumers, with data carrying the primary payload and metadata providing versioning or contextual details. This pattern guarantees the tool's output contract remains consistent with its schema definition. Output schema control pattern. The custom output schema in FastMCP 2 transforms Python functions into AI-callable tools with precise data contracts, where the schema dictates both validation and serialization behavior. Structured content appears automatically for object-like returns, but primitive types require explicit schema definitions to avoid silent data loss. This pattern bridges the gap between Python's dynamic typing and AI clients' need for predictable, machine-readable outputs.
The schema that restricts the tool liberates the client.